Hi, everybody. For those who don't know me, my name is Sreyeesh Garimella. I am one of the mentors here in GameCity, Kajaani. My experience in the game industry comes from working at Blizzard Entertainment, working on titles such as World of Warcraft, Overwatch 2, and Diablo 4, and many other things in the film and animation industry as well. So I had a lot of experience working almost now 10 plus years in the industry, doing a lot of different types of things, and using many different types of tools as well. So my background is as a tech artist, technical director, from both the film and animation industry and the games industry. So in today's keynote, we're basically going to be talking about deterministic NPCs and how NPCs are kind of developed in the games that we will play. So basically, we've all played games where NPCs can make or break games, and the first thing I want to talk about is clear AI from perception to decisions with fixed ticks. Right? So today, I basically want to talk to you about and walk you through a practical way to build NPC AI that feels consistent. And I'll be showing you a demo that I actually built in 3 to 4 hours to kind of show some few examples of code and other things that we'll go through in this lecture as well. So I'm going to walk you through a practical way to build NPC AI that feels consistent, understandable, and production safe as well. The central idea is that our simulation should be explainable at every step. If the player input and the internal state are the same, the NPC output should also be the same as well. That one property gives us a huge advantage when we design, debug, test, and tune behavior during the development lifecycle in our games. So this is especially important in games because players can forgive difficulty, but they rarely forgive unfairness. So when AI behavior appears random or contradictory, trust drops quickly. How many people here in the audience have played a game where you just stopped playing it because the AI was that broken? The game may have looked great, the game may have felt great, but the AI in the game took you out of the immersion. So determinism also helps us preserve trust by making behavior reliable and predictable in the right way as well. So basically, let me see if I can pull up the live demo now. And then we'll also walk through the demo in different steps through the lecture as well. Can you guys see the demo? Yes, I'm just sharing it right now, Vile. So now I'm just gonna hit play in the Unity. And a lot of what I'm gonna talk about also is not just, it can be engine agnostic, not really Unity as well. So let's go ahead and hit play. Hopefully things work. Sometimes during live demos things break. So here I made a simple demo, a top-down player chase. The state is a chase. So you can see that the AI is chasing the player. And once it catches up to the player, for example, it stops. So now I can switch to a different state which is the state machine, for search, and restart it, and it'll start searching now. So if I hide, it'll try to find the player, and then I'll move. And it'll keep trying to find the player. So until it finds the player, sometimes the AI does weird things, like that. But these are the kind of things you can also fix in production, and we will talk about it during the way. So now you can see it's trying to come back and find the player. It found the player, and there it goes. And now this is just a combination of different modes as well, where it's searching again. And this is just, a simple demo to explain how deterministic AI will work, and we'll walk through this whole thing in today's lecture. So let me turn off the screen share really quickly. Perfect. All right. So bad AI, basically, I want to talk about how bad AI also breaks trust, fair AI feels skill-based, and determinism protects trust. So let's think about that as we continue. So I usually start by asking a quick question when I'm developing a game, developing any sort of features like AI in a game. How many have you, like I asked before, and that's why I wanted to keep this in mind, how many of you have had a game experience damaged by bad AI? Let me know in chat. I would love to know. What's like the most recent game where you played, or an old game where you just felt that there was bad AI? Mind's Eye, Outriders, Star Wars Outlaws. Any others? Cool. So as you can see, most people have put their hands up because everyone has seen enemies that ignore obvious information, react inconsistently, or behave in ways that feel arbitrary. So those moments do not just look bad, but they directly reduce player confidence in the game rules, right? So when you guys were playing those games, did you think about how the AI could be improved? Like as developers playing a game? Actually, I haven't played Mind's Eye, but something I could check out for a fun experiment or a YouTube video to see how bad the AI was, really. Yeah, so like Outriders AI felt robotic. Likely they had laser sights on weapons, and you clearly see the laser sight is always on you, and even when you are in the cover, they don't have any vision. Yeah. Just waiting to see any questions are coming up. Then we'll move on. And they follow your movement perfectly. Yeah. So that breaks the game, right? And so for the goal today is not to create perfect AI in this lecture, right? It takes time to develop the perfect AI for your game. The goal is to create AI that is clear, testable, and fair. The deterministic systems give us that foundation. So let's let's think about that. And they let us communicate behavior clearly to players and to the development team as well. So again, I'll open up the demo really quickly just to show if other people haven't seen it, just to kind of show what we're going to be talking about. So we will do direct chase mode now. So as you can see, it's chasing. This is the demo that is going to be talked about during this lecture. It'll catch up to the player. I just did that on purpose to show it as an example. Yeah, and also common stealth game thing is, what was that? Throwing rocks close to enemies. Yep. Sort of like a formula in a way. And then the state machine here, which, you can just restart it on the search. And now it's trying to search and they don't find it. So basically that's it. Okay. Let's continue. So I want to talk about core mental model next when we think about AI. I'm trying a little bit something different in the script, so where it's just not showing PowerPoint slides. Just kind of being interactive with you guys, talking to you guys about what you've seen in games, how you felt how AI acts in games, and then going through examples of the demo that I built as well. So now I want to talk about core mental model. So think of an NPC as a function, right? And the function reads input and internal state, and then emits an action. If inputs and state are identical between runs, the result should be identical. Once we get this trust property, it becomes much easier to reason about changes because outcomes are no longer noisy. In practice, this means that we can reproduce bugs from QA, share exact behavior scenarios with designers, and also evaluate tuning changes with confidence. So instead of debating why did it do it this time, we can inspect the exact state and decision path as well. So let's see. We treat behavior as a data pipeline and not hidden magic, and we also want to make every decision explainable from explicit inputs. And the reason this matters is because bug reports also become more reproducible through the development process. For those who are developing their games right now, are you implementing bug reports during your development process? Reading the logs of how the AI is performing during your development process? Let me know in the chat. Yep, print is my bug report. Yep, it should be everybody's. All right. Let's continue. Something that everybody knows about it, but something that everybody knows about but is lazy to do. But yeah, UE log helps. Yep, UE log definitely does help a lot. And learning how to read bug reports and like troubleshoot, this helps you develop your AI and develop the game a lot better, so it can make the whole game feel better at the end. So 1 second, everybody, while I pull up something to talk about as well. Okay, so let's continue. One of the things I like to talk about is seed and tick and mode and state as well. And these are different, building blocks of AI that a lot of people sometimes forget about when they take a look at, okay, how do we make the game feel better? How do we make it fun and balanced as well? So next, I want to talk about system layers. I want to talk about 1, perception, what NPC knows, 2, decision, what the NPC chooses, and 3, action, how the NPC moves. So for me, I split the AI into 3 layers. So responsibilities stay clean. And the perception defines the information is available. Decision turns that information into intent. And then also the action turns intent into motion into the world as well. And keeping these layers separate is critical because it lets us improve one layer without destabilizing the others. When teams struggle with AI debugging, a common root cause is mixed concerns. For example, sensing logic gets embedded in movement code, or state transitions are buried in physics callbacks, for example, and this structure avoids that trap and keeps the behavior explainable. So now, actually, I'm going to pull up a sample piece that I wrote just for this lecture. Let's see if we can pull this up really quickly to show the code. One second. Just organizing myself here so that way it's easier to explain. Can you guys see my code here? 1 second, hold on. That's the wrong thing. I only have a second monitor here. I'm going to see if I can share the application here really quickly. There. Can you guys see that? Okay. Okay, cool. Alright, so basically, this is a lot of lines of code, but I'm going to find a specific line of code to kind of walk you through what I did and how I approached this demo for you all to explain it. So the way I like to work is I always like to, if I'm like want to explain something, I always want to show how I wrote it, right? And we can always look at different code in different ways. So now let's say just ignore it, right? I just wanted to show, is player visible? Is player visible basically is what, perception is player visible. So we can also find where that is in the beginning here as well. So decision is in the branch logic and updated agent. So basically when I write the code, I like to think about it in different chunks. And I want to make sure that we have all the code for the AI saying, hey, the update agent does this, the state machine decision does this, and then the utility decision does something else. And then also, we can do, the state machine is over here. As well. And I'll also provide the GitHub repository for everybody to take a look at. It's live as well. So just wanted to show how you think when you want to develop the AI and the type of code that you want to develop, even for a simple demo like this. So you're probably asking, why are things written this way, right? So the reason why I wrote it like this is because swapping decision logic does not require rewriting movement. Upgrading perception later does not invalidate existing brain modes as well. And we can highlight, I've highlighted the methods as you can see here for even the state machine. And then also the other ones and the utility decision as well. Here. It'll be better for you guys to see the code also in the repo, which we can have it accessible later after the lecture. So it may be hard to just read on this small screen right now that I have as well. So do anybody have questions? Does anyone have questions regarding what I just showed before we continue? Really is typing something. So yeah. Yep, I did, because I wanted to show that as an example that how you can really craft the way your AI moves as well. What is really typing? So yeah, if anybody else has any questions, do let me know. I want to keep this interactive as we go, not just me talking as well. And let's keep an eye on the time. Yeah, just about to start simple AI. Harvata leverage engine stuff. So I guess think on the side should have manager tracking things. Yep. So I want to talk about determinism constraints next, basically, with you guys. With determinism constraints, let's think about fixed tick loop, single-seated RNG, and also stable update order. Now, let me know in chat if some of this is what you guys have been already working with, and then maybe next time in the next lecture I can do more of a low-level detail as well. A lot of this is very technical. So if you haven't messed with it before, it can be sometimes difficult. So do let me know if you have questions. Determinism does not happen by accident. It comes from a few non-negotiable constraints. First, decisions must happen on fixed simulation ticks, not directly on variable frame time. Second, random values must come from one seeded source. And also third, for this, the one I discussed, update ordering must always be explicit and stable. If any of these constraints are violated, repeatability starts to degrade, and you may still get behavior that looks okay, but it becomes like much harder to debug because outcomes differ subtly between runs. Also, so basically, the fixed tick or the update accumulates real time and then steps in fixed sized increments, and then seeded RNG. Also, all randomness flows through deterministic RNG state as well. And this can change depending on how you develop it on your project. And then we also discussed the update order. This is also step simulation. It's always updates players first, then each NPC, then increments the tick as well. And again, since it's really hard to read on Discord, I will be providing the repo for you guys after the lecture is done. So if you're curious about it, in the repo, let me see if I can pull that up and see if that's easier. I'll show you the files. One second, just pulling everything up here. Okay, perfect. And then I'll pull up the other one really quickly. One second, everybody. And then deterministic. G. Where is that one at? Perfect. Okay. So basically, yeah, now I'm going to share momentarily as well. One moment. I was just pulling them up off screen, so that way you don't have to worry about it. And now, let's see if I can move Discord out of the way. And then we can talk about this. Can you guys see everything clearly here? These are the files that we're going to be talking about in order here. Cool. All good? Awesome. I'll minimize Discord. So in this walkthrough, I want to kind of walk through things in order because it matters and it matches the runtime pipeline that I built in the demo as well. So we're going to start with the deterministic model as well. I think it's going to be a lot easier to read it here in the repo as well. So that way you guys can see the links. I can even share the links with you here during the chat. One second. If you wanted to just check it out yourself. All these three links are here. we start in the deterministic world, right? This is where a lot of the first parts of the logic are written here. So this file, where I wrote a lot of the code here, owns the simulation flow and NPC logic as well. And then we can take a look at the deterministic. We can take a look at the player to target control as well. This captures the input as well. And then also for the deterministic RNG, this drives the repeatable randomness. So this file order keeps the story coherent. So that way, all these files are built with purpose. So that way you can see what the logical order is when you develop your AI. So 1 second, just trying to organize myself here. Oh, the repo seems to be private? Okay. I'll have to make it public later then. So as you can see, when we're talking and going through the code, let me see here. Let me see if I can share it again. Sorry, don't have many monitors to organize myself here. Here's the demo again. So basically, let's restart. So now I basically want to talk about how my thought process was to build this demo for us. So for the controls, I use standard controls, WASD, and you can also use arrows as well in the demo when you download it yourself as well. And when you download it, I'll make it public after the lecture is done, and it'll be called a sample scene here in the projects. So there we go. And then also I added a sprint run as well. So that way you can do that. So I'm just like pausing it with spacebar. And then R is to reset the player and the NPC, so that way you can experiment and use it. So I just wanted to talk about how you guys can also use it. So later, if you want to watch the video, you can learn how to use the project yourselves as well. And then to switch between the different modes to learn what each mode does is 1 is the direct chase mode, 2 is the chase mode, and 3 is the utility mode, and this one is the search mode as well. And then pause is for pausing, of course, and then resetting. So these controls are basically intentionally minimal so that the focus remains on the behavior and code when I developed this demo for us. So it's not on gameplay mechanics. So basically what I wanted to do during the talk, I wanted to be able to reset and just keep things, simple so it's explainable for you guys during the lecture as well. Okay. 1 second. How are we doing on time? We seem to be doing okay. So one of the things that I wanted to talk about, actually I figured out a way I can share the code as well, since you guys, I want to talk about that with y'all in person. 1 second here. Maybe I can paste it into Discord chat, and then we can just talk about it that way. Because So I'm about to paste some code into the Discord and talk about start and update, basically. And we'll talk about it right now. Let's see if it's formatted properly. There we go. Okay, cool. So I can do it that way. So this block that you guys see in the chat here right now is the engine of the lecture, basically. In start, we want to convert the tick rate into a fixed delta and initialize the deterministic RNG from seed. In update, we collect the frame time into the accumulator, and then consume it in fixed size simulation steps as well. So this pattern solves a major real-world issue, frame rate variation. So even if rendering is slower or faster on different machines, simulation decisions still happen in deterministic tick increments. Just out of curiosity, do you guys understand the code that I wrote? Let me know in chat. I just want to see what your interpretations are within the code. So you guys can chat about it. So this pattern basically here solves, as I was saying, this pattern solves a major real-world issue, frame rate variation. So even if rendering is slower or faster on different machines, simulation decisions still happen in deterministic tick increments. And that is exactly what keeps AI behavior stable and reproducible. So basically what each part does, right? The tick time delta, we're going to just kind of break it down here a little bit. So the tick time delta converts ticks per second to second per tick. And the math Fmax that you see right here in the Discord chat is guards against the invalid zero or negative rates. And then the RNG, the new deterministic RNG, ensures one explicit random stream as well. And then also the accumulator that you see in the code that I wrote here. I can't show it, but I'm just talking about the code that I pasted in the lecture chat. Is that it stores unprocessed frame time, and then the while step simulation here catches up with fixed steps even when frame time varies as well. The reason this was written the way it was because I wanted to keep the logic independent from monitor refresh and also frame spikes as well. So it makes the AI timeline stable and also testable. Is it possible to use the fixed update for this? Basically, we sure, yeah, it should be possible for that. Basically, homemade fixed update. We only step in update after a certain time. Yeah. And so for the purpose for this, guys, is that the deterministic simulation is for the deterministic simulation clock as well. Hopefully that means. I wonder if UE BTSs have this ticking approach built in. I have to think about that because I know the way I solve a lot of AI issues is with tick in general in UE. So I'll have to get back to you on that. Okay. So I also want to show this next set of code for you guys in our chat here. Kind of like doing it this way, actually. It's kind of fun to be more interactive with y'all in the audience. I was trying to figure out a way on how to teach the code, because usually when I teach in person, it's a lot easier to show it on screen in person than on Discord on a small monitor. So that way I can just give you the repo and you guys can take a look for yourself after the lecture is done. So let's talk about this code next. This one here. Input handling and presentation controls. So the input block is part gameplay control and part lecture tooling. So basically, I'll show you the demo, right? 1 second. So basically, I wanted to talk about the tick here. Here's the tick timing. Here's the seed. Here's the distance and the state that we're in. So that's what I'm talking about here and how the demo was built. And you can see the tick timing there as well from the previous time we talked about it. And then I calculate the distance as well. So where was I? On the input. So when I left out on talking about how this is all part for the lecturing tool that I made. So the reset and the seed switching are the most important keys for the demo that I built to understand how the AM tools work, because they let us improve the deterministic replay and controlled variation live as well. And mode switching within the demo lets us compare decision systems under the same world setup. This is what I meant that like this lecture can get a little technical. So if you didn't notice that these controls are simple and explicit, so there's no hidden state machine around presentation controls, so that it keeps our demo live and robust and is easy to recover when I need to restart a sequence and with you guys to explain it. So that's the reason I developed it that way. So the reason why I wanted to do it that way is so I wanted to compare. I wanted to show you guys the A/B behavior comparisons quickly. Seeds changes are explicit and auditable as well. And the purpose for this was just for the live demo readability also. Okay. Cool. Let me know if I'm going too fast. If you have any questions, do let me know. All right, so this is the next line of code that I want to talk about. Okay, perfect. So this is scene initialization, guys. The life cycle split here is deliberate. The initialization scene is a one-time construction for static world objects and view setup. Reset round is recurring runtime state reset, and separating these responsibilities avoids accidental duplication and keeps resets fast. From teaching perspective, this also, like we can rerun a simulation without rebuilding the world. And then the geometry also stays fixed while the dynamic state is restored to a known baseline. So when you're developing and testing your own AI, you want to think about it this way as well. So basically, the initialization scene, the way I set up the demo, and when you develop your game, it builds the camera, the ground walls, obstacles, and now this is within Unity, players and agents once. And then the initialized flag avoids duplicate scene construction as well. And then the reset round resets dynamic state every run. And the reason why I did it this way is because I wanted to prevent hidden carryover between rounds. And then I wanted to keep resets cost low and behavior consistent as well. So these are the kind of things that, even for a demo, I think about as well. So just think about it. When you're developing, you want to keep thinking about these things consistently with your AI to improve your game. Perfect. Okay, so we're getting close to finishing up soon. Next, let's talk about this here. Reset round and known baseline, right? This still has to do with AI and determinism. Reset round is where determinism becomes operational. So we reset tick counters, simulation timing, pause state, and RNG state before reinitializing actors, positions, and memory fields. So this gives us a clean episode boundary every time. This is one of the most important production habits in deterministic systems, and it always makes reset explicit. So if any stale state survives across rounds, repeatability is weakened and debugging gets harder. So basically here we reset the timing in RNG, repositionings of the player, repositions obstacles with deterministic RNG, and then also we reinitialize each agent state, including wander, DR, and last scene and timers as well. So the reason we want to do this is because we want to prevent stale state from contaminating demonstrations or make an exact replay possible under the same seed and the same inputs as well. Okay, I think we're making some good progress here. How are we doing on time there, Jones? I think we're doing okay. $12 minutes left? Okay, cool. So, yeah, it's getting a little bit more technical, so I want to make sure that I have enough time to cover everything that I wanted to cover for that you guys wanted as well. So where was I? So next, we're going to talk about step simulation ordering. And if I don't have time to finish, of course, I will be providing the repo public. I'll give it to Jones to share to across the team so you guys can learn and understand things from the repo as well. All right. So here, we're going to be talking about step simulation ordering. Oh, something is happening. 1 second, everybody. That was weird. Am I still here? I don't know. Something happened to my computer. So I don't know if you guys heard that weird noise. Yeah, okay, cool. So where was I? I was in step simulation, yes. You're still here? Okay, cool. Okay, I lost my place. My computer did a weird thing, so now I'm a little like flustered, but we will find our place. 1 second. boy. Okay, so I found where we are now. Sorry about that, guys. So basically for step simulation ordering, this method looks small here, the code that I shared in the chat with y'all. But the ordering is crucial. We always update the player first, and then each NPC, and then increment tick as well. That ordering creates a stable causal chain where each NPC decision reads the same stage of a world state. If ordering drifts, you get hard to explain behavior where one agent is effectively one substep ahead of another. So fixed order avoids that class of bugs and keeps the replay consistency as well. So basically, it's going to be for fixed sequence for every trick, every tick. And the reason why we're doing this is because we want to avoid race-like ordering bugs, and also it makes decision timing more predictable as well. So for the purposes that stable causal chains per tick are modeled this way. Okay. Then, let's just double check on the time. We have 10 more minutes left. I'll try to move quicker. Now we're getting into more nitty gritty here. So here, I want to talk about player input sampling. Now we're breaking down the code even further. Input is sampled every rendered frame, but only consumed in deterministic simulation ticks. The division is practical, so we still capture responsive user intent, but decision making remains tied to stable tick timing. And then using raw access values is intentional, but smooth access can introduce additional variability and lag behavior that complicates deterministic debugging as well. So to break this down, the code that I shared, basically we're capturing the directional intent and sprint flag, and then we're also using raw access to avoid smoothing drift as well. So the reason we do this also is because raw inputs are more deterministic and easier to reason about. And it gives us a clean input signal for simulation ticks also. Okay, so just seeing where we are to see what we can do here before we run out of time. We're just getting really low detailed. For those of you working on the game, what has been the most... I know I see Yari from Neon Coco and Auntie from Neon Coco as well. And any others, what has been the most difficult thing for you about developing your AI? What challenges have you come across? How have you solved them? Let me know in chat. Would love to open up a discussion. Because when we're going to go through the lecture now, it's going to be a lot more technical. We'll take a lot more time as well. Jonathan? Is Jonathan there? But from your perspective, matching animations with AI behavior has been the hardest task so far. Okay, interesting. We can talk about that definitely on a more low-level talk, one-on-one as well. So if you guys want, I can make a separate lecture on that also. Maybe to replicate faulty behavior if the issue does not appear each time. Yeah, these are each separate lectures, for sure. Well, cool. I think we're getting close to running out of time. Jones, I don't know if you're still there in the chat or not. There's a lot more that I wrote down for you guys, but this would have been an hour and a half lecture for sure. But hopefully I covered a lot that you guys wanted to learn about determinism AI. It was a very simple demo, but it was a lot of a lot went into the demo to show what you could learn from it as well. So you can break apart the demo yourselves, and I will make it public. Actually, let me do that right now before we end the lecture. 1 second. And let me get the... And I'll make the lecture and I'll share everything as well. So here you go. Here is the lecture. It should be publicly available now, the repo. You should be able to access it and learn from it. And if you have any questions, you can go ahead and share the screen here. I'll share the screen here. And one best way to ask me questions, if you do have any, is through raising an issue here in GitHub. So that way I'm able to see it directly there. And you can ask for help on the project. I have a README here that basically shows where everything is. This repository contains a small Unity demo project built for a keynote explaining deterministic NPC logic for FPS third-person roguelike games. And so there it is. And then you can walk through the demo here, see what everything is organized basically for you, all y'all. So, does anybody have any questions left?